Okay, today we're going to study more advanced mathematics. So this is the first chapter. And the first chapter is still about the fractions. Okay, we're not going to talk about equations, how to solve a story problem using equations. So the first chapter is still about fractions, but a little bit more advanced than what you think. Okay. You know, in the intermediate math class or pre-algebra, you have learned similar problems maybe, but that's different levels. Okay, so let me begin with rational numbers. You know, by definition, rational. What is the definition of rational numbers? Rational numbers, right, is a number can be expressed as a fraction. Okay. But it's also if we express it in decimal form, and that would be a decimal number with terminating or repeating digits. Okay, so those are called rational numbers, and the rational numbers are rational numbers. Okay, and I'll give you some examples. Okay, those are the numbers like a 23.87, and this is a rational number. Okay, it's in decimal form and was a terminating number of digits. Okay, and then some. If you put a bar here, that means 23.878787 and repeating. Okay, this is also this can be expressed as a fraction, right? And so therefore it's it is a rational number. Okay, let's maybe you already know that, right? How do you express this as a fraction? Okay, so if it's have a 2 digits repeating, then this will be 23 plus 87 divided by 99. Okay, then you combine them, you get the fraction. Okay, so you can let's see. So that would be 23 times 99 plus 87 divided by 99. Okay, then you do the calculation. You will get the very large numerator. Okay, so 23 times 99, okay, plus 87, right? That's 2,364 divided by 99. Okay, so this is a rational number by definition because it can be expressed in terms of it can be expressed as a fractions. Okay, to integer will divide by integer. Okay. So this number is pretty strange, right? 0.9 bar. Okay, 0.9 bar, but it means 0.999. Okay, repeating. Now, if we convert it to a fraction, you will be surprised. Okay, that will be 9 over 9, and that's going to be 1. Okay, so rational number in the decimal form repeating digits, this actually can be viewed as like a limit. Okay, so this is going to be actually 0.9 plus 0.09 plus 0.009 and keep it going, right? So each of them, it's a sum of infinite many terms, but each term is getting smaller and smaller. And later on, if you study the so-called series, then you can find out the limit. Okay, so the limit, if we have a finite many terms here right now, okay, the finite many terms, and then together the limit is actually 1. So yeah, we are going to talk about this a little bit later, but I just tell you 0.9 bar, if we convert it to a fraction, You just 9 divided by 9, okay, which should be equal to 1. Okay. Irrational numbers, which are numbers not irrational. And there are many irrational numbers. Okay. Some numbers, for example, such like the square root of 2 cannot be expressed as a fraction. Okay. All right, so take a look at the example, first of all. Okay, so if we have a 0.5 bar plus 0.21, how do you add them together? In order to add them together, you have to change them to the fraction. Okay, otherwise it's difficult. So first of all, it's a 5 over 9. Second one is a 21 over 99, right? 21 over 99. Okay, now both are the fractions, so you can add them together. You get a common denominator. Okay, you have to multiply 11. It's 9 times 11. So then you can get a 99. Right? Okay, so now the numerator is 55. That will be 55 and plus 21. The denominator, sorry, I have to erase this. Yeah, the denominator, yeah, you have a common denominator, so it's 99. So the answer will be 76 over 99. All right, over 99. All right. Now, if n is the integer, okay. Okay, 1 over n is called the reciprocal of n. Okay. Now this is of course it is a rational number, right? It is a rational number. My question is, when this is a terminated decimal, that means you have a finite many digits after the decimal point. Okay. So we have an important fact. Okay, you have to know that. So this one is a terminating decimal. Okay, if and only if this n only contains a factor of 2 and 5. That means it can be written as 2 to the power p, 5 to the power q. It does not contain any other factors. Okay, so when n is 3, okay, if n is 3, because 3 is not 2 and 5, so this one cannot be a terminating decimal. It's actually it's 0.0333. Okay, and but 1 over 2, yes, it's 0.5, right? And when 1 over 10, right? It's 10 is 2 times 5. It contains 2 and 5. That's going to be 0.1. Okay, so this is a terminated decimal. So in general, a reciprocal is not going to be terminating decimal. Okay, so very few rational numbers are terminating decimals. Very few. Okay, in general, they always have repeated digits if you express it in terms as a decimal. Okay, and some numbers, some even get very long, like 1 over 23 when n equals 23. And you can use a calculator. You will see that it's going to be 0.0 and 4,3,4,7,8,2,6,0,8,6,9,5. Wow! So it looks like it is not a repeating decimal, right? But actually, this part will be repeated. Okay, but there are so many digits here, all different. Okay, this will be repeating. Okay, so there are some reciprocals. It's pretty strange, you know. It's when you express as a reciprocal of something, right? 23, 1 over 23. There are so many digits are different, not repeated. Okay, it's a very long line. It's not like 1 over 3. It's going to be like 0.3333. Okay, so at the very beginning, you think maybe this is this is not a repeating decimal, and actually it's not. Okay, this is still repeated. Okay, so you have so many digits will be repeated. Okay. Okay, this will be a very long line. Now the okay, so first of all, let's look at what is the radical square root of a number. Okay, by definition, okay, given a positive number, let's call it a greater than 0. This is called the square root. The square root of a. Now this is a positive number, and it is going to be the number whose square is going to be a. Okay, so is by definition is a positive number. Okay, and whose square is equal to a. Okay, so in other words, step 1, that's positive. First of all, yeah, the second is the square is equal to a. So there's only one such number there. Okay, square root, for example, square root 2 is some number. Okay, whose square is going to be 2. Okay, whose square should be equal to 2. Okay, and the square of 3, its square is going to be 3. And the square of 4, its square should be equal to 4. But we know that, right? 2 square equals 4. So therefore, square of 4 is going to be 2. Okay. But in general, square root of a is an irrational number. Okay, if a is not a perfect square. Right. So in general, if a is not a perfect square, okay, then square root of a is still defined, right? In general, a positive number, okay, is an irrational, okay, irrational number. Because that means it cannot be expressed as a fraction of 2 integers. Okay, it's not easy to prove, but you can try to prove for the square root 2. Okay, trying to prove that square root 2 is an irrational number. Now, when you come to the solution, okay, how to, if we want to consider this equation is a positive number, then it has 2 solutions, okay, because square root a is a positive number. Okay, itself it's positive. So you want to get another solution, you just put a negative sign there. Okay, so just since because we have a plus minus a, and that is going to be a. Okay, so therefore x is going to be plus minus square a. You have 2 solutions. Okay. Well, then you are wondering. Question, right? Okay, does x squared equals -1 have a solution? Okay. And what is the solution? Right. So then, well, sometimes, yeah, sometimes not. Depends, right? So it depends on where you want to talk about. In the real world, there's no solution, but you can introduce a new notation it's kind of like a fake solution, say it still have a solution, but I try to use a strict notation. Okay, I'm going to assume it has a solution. Okay, although the square of any number, I don't know, the square of any real number is going to be positive number. Okay, so that's what we're told, right? Negative becomes positive. So the square of any real number is a positive number. So that it has no real solution. Okay, so my conclusion is no real number is a solution of this equation. Okay, but that's not the end of the story, So if you were, born 500 years ago, right, then you stop here. Okay, no solution. But someone still want to solve this equation. Okay. Yeah. So you have to introduce some notation. I called introduce. So don't be hesitate. Yeah, introduce a new notation. Okay. Okay, it's called I. So this I is initial of the imaginary. Okay, so this I square is going to be -1. Okay, so once you get, then you get the complex numbers. Okay, so then we get, and this will be you are studying in high school, not right now. Then we get complex numbers. Okay, complex number will be written in the form like that, A plus BI. Okay, its combination such as 2 minus 3i. Okay, 2 minus 3i. Okay, this is a complex number. Okay. Okay, and you can do the multiplication, and you still, then maybe people will argue with you. Okay, there's I does not exist. How can you do the computation, right? I does not exist. Well, it depends where you live. Like you live in, if you live in a 3-dimensional space, it's hard to imagine an object in 4-dimensional, 5-dimensional space. So our number, if you put it in along a line, we have a coordinate line, so 1-dimensional. But complex number, you have to use a 2-dimensional plane to describe it. Okay, just 1 dimension above. Okay, so you can do the computation, no problem. Right? 2 minus 3i, when you want squared, and you can do just like usual, 2 square minus 2 times 2 times 3i and plus 3i squared. And you get another form of same form, complex number. Here's a 4, and this is going to be 12i. And here the 3 is a 9, 3 squared, I squared is going to be -1, remember, right? So that will be -5 minus 12i. So that is, okay, you can do multiplication, you can do division, all kinds of computation. So that's why you have a so-called complex number. Now we're not going to talk about here, spend more time to study here, okay? So I think Rebecca already learned something about that, right? Yeah, so now we have to think about the nth root, okay? Then nth root of a, okay? We generalize, the square root of n, right? The square root of a is the nth root of a, but that's only, for the simplicity, I assume that a is positive, okay? So the nth root of a denoted by a to the 1 over n, or this, doesn't matter. And this is going to be the positive number. okay, such that the number to the nth power is equal to a. Okay, so what is what is the third root of 5? Okay, I'm sorry, something wrong with my pen. Yeah, let me erase this. Okay, so the third root of 5, right, is a number, and such that its cube is going to be 5. But what is the exact value of this third root of 5? You have to use a computer to estimate. Okay, right? But I know that, yeah, the third root of a cube, right? Because this cube is going to be 8. But I know 2 cube is going to be 8. So it's clear that that implies the third root of 8 is going to be 2. Okay. Right. The third root of 8 is going to be 2. And similarly, so if we have the power m over n, okay, a to the n over n, by definition, this is going to be a to the 1 over n first, and then to the n, to the power n. Okay, that's the definition. So if I want to find out, yeah, let me, okay, that's yeah. So if 8, okay, that's going to be, 2 over 3, right? To the power 2 over 3. That's by definition is 8 to the 1/3 and the square. Okay, so that is going to be 2 square, right? That's going to be 4. Okay. All right. So now you can have a, this is yeah, a to some power. This can be any rational number is defined, right? So we can also, yeah, in mathematics, a to the alpha, you can define this. Alpha can be any real number, okay? Can be defined for any real number, okay? Alpha, okay? And once you define this, then we do have several formulas. Some formulas we want to, yeah, we want to know that, right? So a to the alpha times a to the beta is going to be a to the alpha plus beta. Okay. So a to the alpha, if we have a negative sign, a to the negative alpha, that means is 1 over a to the alpha. Okay. Then a to the alpha minus beta. This can be written as, okay, this can be written as a to the alpha, right? A to the negative beta. And that is going to be a to the alpha times 1 over a to the beta. And that is, right, that's going to be a to the alpha and a to the beta, right? And yeah, so that's good for me. Okay. Another important formula is a to the alpha and to the beta is going to be a to the alpha times beta. Okay, let's understand the last formula. Assume a alpha beta integers, okay? So a square and the cube, right? So that means, yeah, why is 2 times 3? Okay. The question is why is a going to be 2 times 3, which is a to the power 6? Because a square cube, this means a square times a square times a square, right? It's because cube. Okay. Then you get a to the, using the first formula, 2 plus 2 plus 2, right? How many 2's there? There's 3 2 here, so that's why a 2 times 3. Okay. Okay. right? All right, so now let's take a look at the square root of 12. Square root 12. Okay, square root 12 can be written as 4 times 3, right? That's 12 is 4 times 3. Okay, so that can be square root 4 times square root 3. Okay. But square root 4 is going to be 2. So this can be simplified as 2 times square root 3. Okay. Yeah, remember square root 12. I'm sorry. Where's my file? It's gone. Just a second, okay? Sometimes it's disappeared. It's not very stable. All right. All right. So square root 12 is just 12 to the 1/2. Okay. Now if you use this notation, right? So it's 12 to the 1/2. And that would be 4 times 3 to the 1/2. Okay. And that will be 4 to the 1/2 times 3 to the 1/2. And 4 to the 1/2 is square root 4. So that's why that's a different way to express. And then you go back to the traditional notation. Okay, this is traditional notation. Okay. All right. All right, so now the next problem is coming from the mass count. 4 to the power 11 plus 4 to the power 11 plus 4 to the power 11 and plus 4 to the power 11. And to the 1/4. Okay, so we're trying to simplify this. Okay, how to do that? Well, that when you simplify some expression, you have to follow those formula. You have to use those formulas. Don't create your own formula. Okay, so the important, yeah. So you use a formula, and then in each step, use the correct formula in each step, then you will get the correct answer. Okay, don't create your own formula. Okay. So this, how many fours there? How many terms there? 4. So it's 4 times 4 to the power 11. Okay, now this 4 and that 4 is the same 4. So that's why 4 to the power 1. So that's a 4 to the 1 plus 11. Right? And then you have a 4 to the 12. Okay. And then finally you use a formula, it's 12 over 4, right? Alpha times beta. And that is a 4 cube. Okay. 4 cube is answer. So 64 is correct answer, yes. Sometimes we just leave like that. Or you can use you can write down. Yeah, you can use a 64. All right. All right. Now the next problem. I want to simplify the expression, okay, 2 to the 2020, okay, minus 2 to the 2021, divided by 2 to the 2019. Okay. Okay. To simplify this, you have to, what I'm going to do. Each of the number is very huge, right? You factor to the 2020. So you get a 1 minus 2, right? 2 to the power 1. and divide by 2 to the 2019. Okay, 1 minus 2 is just -1. So it's going to be negative. Okay. And then you use the above formula again. The difference of those two numbers, which is 1. So it's -2. -2 is the answer. Okay. Such complicated number, finally, you have to simplify. It's just -2. Okay. All right. So now I'm going to introduce a notation called n factorial. N factorial is a product of all the digits from 1 to n. Okay. This is actually a huge number. For example, 2 factorial is just equal to like 1 times 2, 2, 2. But 3 factorial is going to be 1 times 2 times 3, which is 6. Okay. And the 4 factorial is 1 times 2 times 3 times 4, which is 24. Okay. Now, when you look at this here, you can also, this is a 3, right? 3 factorial. So it can be written as 3 factorial times 4. Right? 3 factorial times 4. Right. Right. After we understand this, and you know that 2021 factorial, right? That's a lot. This is a huge number because can you imagine all this number multiplies this out, right? However, this first 2020 numbers can be also simply written as 2020 factorial. Okay, you can always express like that. Okay, and similarly, you can write 2019 factorial. Then you have a 2020 and 2021. It's a product of those 3 numbers, right? So, okay. So now understand this. I'm going to ask you to do the next problem. Simplify, okay, 2021 factorial minus 2020 factorial divided by 2021 factorial plus 2020 factorial. Okay. Yeah, please simplify this. And when you get answers, post to me directly, okay? You find my name, click, that's called host. Yeah, then post the answer to me privately. Now, the answer cannot be 0, okay? Why? If it's 0, the numerator must be 0. But clearly the numerator, there's 2 numbers there. They're not equal, all right? So when you get an answer, think about it, use a common sense, right? The numerator is not 0, then the fraction cannot be 0. If the numerator is not 0 just because there's 2 terms in the numerator, they're different. Okay. Okay, so far I haven't got any correct answer yet. So those who submit answers, please read it. All right. Okay, Rebecca, your answer is correct. Yeah. she was not confident. She just said, wait, that is wrong. Okay, that's correct, I think. All right, let me double check the answer. You posted to maps. Yeah, your answer is correct. Okay. Now you don't feel confident about this. All right. So let's simplify this. And this is a huge number. So we have to find the common fact, find, 2021 factorial is going to be 2020 factorial times 2021, right? Minus 2020 factorial, right? That's a huge number. And here 2020 factorial is going to be the same, right? You express it like this. Okay. Then you really don't need to worry about what is 2020 factorial. I call it X. Okay. Then here's X times 2021 plus X. Okay. Right. So here X is going to be 2020 factorial. It's a huge number. So now what do you get? The numerator is 2020 X, the denominator 2022 X. So that X is gone, right? So it does not show up. And after simplifying, the numerator divided by 2, the denominator divided by 2, and that is answer Rebecca got. She erased it. All right. So that is correct answer, right? Yeah, it's almost equal to what? Okay. Do you see that? Okay, so if you didn't get this, let's try to simplify another problem, another expression. Okay. So this time I give you 1001 factorial, 101 factorial minus, okay, 99 factorial, 101 factorial plus 99 factorial. Let's do this problem. Okay. Erica, how come it's one? No, sorry. I didn't get it. Yeah, okay. Kylie got the right answer. No. Yes. Okay, anyone else? All right, I got two different answers. I guess three different answers. Anyone else? Let's see, who is here? Eric? Eric Jing? Okay, so let's do it. So first of all, I know that 101 factorial is going to be, right, 1 times 2 times 3 all the way to 99, 100, 101. So this part is 99 factorial. Okay, so the expression here is 99 factorial times 100 and 101 minus 99 factorial. Oh my God, this pen. Okay, so okay, so then denominate. Okay, so there's a common factor here. This common factor, you can take it out, cancel it out. They're all deleted, right? It's going to be 100 times 101 minus 1. Okay. Then it's 100 times 101 plus 1. So that's it. If you multiply this out, okay, you will get okay. Right, so what is the numerator, right? I think Emma's answer is correct. So 100, 100 minus 1 is 99. 1, 0, 1. Okay, so this is answer. Great. So now, we take a look at the next one. Can we simplify this expression? Okay, if you only have a few terms, probably you can do it directly. Okay, but if you have more terms, then you cannot use can direct add 3 terms together. You have 100 terms. For example, 100 terms here is 100 times 101. Okay, how do we combine them into one fraction? Okay, and those are the fractions, so you eventually get a fraction, right? After it all together. Okay. All right. So what is the trick here? How can you solve the problem? Here's the idea. Okay, you have to cancel lots of terms, otherwise you're unable to solve it. So what I'm going to do is, I notice that, okay, this is going to be 1 over 1 minus 1 over 2. And then 1 over 2 times 3 is going to be 1 over 2 minus 1 over 3, because 3 minus 2 is always equal 1. And then 1 over 3 times 4 is going to be 1 over 3 minus 1 over 4. And keep it going. 1 over 100 times 101 is going to be 1 over 100 minus 101. So on the left-hand side, you add all together, right? On the right-hand side, if you add them together, this will be canceled out, right? So what is left is only the first term and the last term. So the sum is just going to 1 over 1 minus 1 over 1 over 1. Okay, then if we simplify this, you get 101 minus 1 is 100 divided by 101. Okay, that's it. So this is how do we solve the problem. Okay, now in general, right, 1 over yeah, this will be n plus 1 minus n. So you will get n over n plus 1. Okay, this is the general formula. How about there's a 2 here? N plus 2. In that case, you will get n plus 2, but n plus 2 minus n just 2. Okay, so there's 2 here. Right? So you can also express in the form like that. Okay, so I'm going to ask you to simplify. Okay, simplify the following. 1 over 1 times 3, 3 times 5, and 5 times 7, and 99 times 101. Okay, please do this problem. Okay, anyone has answers? Okay, well, basically you have to, you have to submit, right? You just decompose it, right? But they're not exactly equal. You have to divide by 2. 3 minus 1 is 2. And the same here, 3 times 5. And this is 1 over 3 minus 1 over 5. The numerator you get 2, so you have to divide by 2. Okay, so you keep it going. And 99 times 101, that's also going to be 1 over 99 minus 101. Okay. So now, add them together. So the sum on the left-hand side is going to be sum of the other terms on the right-hand side. And you will see that all the terms cancel out when you add them together. You only got the 101 minus. Okay, so that's it. That's it. So it's going to be 101. Here's going to be 100. 100 divided by 2 is 50. So that is the answer. Okay. All right. All right, let's see. Here's next one. It's a little bit difficult. simplify the product of those perfect squares. Okay, how many terms here? You have a 99 terms, right? From 2 to 100. Okay, from 2 to the 100. Okay, let me explain to you how to do it. So when you see so many terms, you should know we are going to cancel some terms, okay? We're going to cancel some, otherwise you're not able to simplify. So they must have some common factor. So the numerator, the first term is 2 square minus 1. 1 is 1 square, okay? Here's a 3 square minus 1. Here's a 4 square minus 1. And here's a 100 square minus 1, 100 square. Okay? So 2 square minus 1 is 2 minus 1 and 2 plus 1. 3 square minus 1 is a 3 minus 1 and 3 plus 1. And the 4 square minus 4 minus 1 and the 4 plus 1. And we keep going. 100 minus 1, 100 plus 1. The denominator is 2 square, 3 square, 4 square, all the way to 100 square. Now, am I able to cancel some terms? The answer is yes. I only look at those minus terms. It's increased. So it's going to be 1 times 2 times 3, all the way to 99, okay? And here, 3 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. So it begins with a 3, 4, all the way to 101. Okay. All right. I think we can cancel some terms. Why? There are many terms are identical from 3 to 99. Okay, from 3 to 99, right? They're doubled, right? So from 3 to 99. Okay, so those group, this can be canceled out. Right? This can be canceled out. So from here to here, from here to here, here's 99. And from here to here, they all canceled out. Okay, what is left to the numerator is 1 times 2. And here's 100 times 101, right? And here's 2 square times 100 square. So I still can do some cancellation. 100. Yes. So I got 101 divided by 200. Okay, so that is answer. All right, finally, I want to talk about giant fractions. Okay, we know that like this, we know how to simplify it. Okay, I can do step by step, right? 1 over 2, right? Then I got 1 plus 1/2 3 over 2. Then I turn upside down. I got 2 over 3, right? Then I combine them. I got 5 over 3, right? 1 plus 2 over 3 is 5. Then turn this upside down, I got 3 over 5. So it's a fraction, right? It is a fraction. Okay, so this is yeah, this everybody knows that how to do it. It's as long as you be careful. Okay, but how about the following? X equals 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus, and keep it going forever. wherever. How many layers there? Infinitely many layers. Okay, assuming you have a billions of rays. Well, what is a what number x approximate, right? X does x approximate. So yeah, this is equal to what? That's our question. Okay. This is our question. We're trying to figure it out. How do you solve this problem? Well, do you notice that this portion, okay, is the same as the whole fraction, right? Do you agree, right? So that means this is also x. Right? So if that above x makes sense, has a value, then under this one plus that should be this circled by yellow color, right? It also makes sense, should be the same value. Now, if you agree with that, then I can determine the x. So because x is going to 1 over 1 plus x, and how do you solve it? How to solve it? Okay, clearly x is a number greater than 0, less than 1, right? Because less than 1, clear, it's 1 over 1 plus something, right? Okay, so let's find out that x. Okay, this is not a linear equation. How do you solve it? Just multiply both sides by 1 plus x. Okay, then you get a quadratic equation. Okay, then what? Then have x squared plus x minus 1 equals 0. Hey, how do you solve the quadratic equation? Quadratic formula, right? We learned the quadratic formula. Okay, so x is going to be 2 times 1 negative b plus minus b squared minus 4ac. So what is inside is going to be square 5 over 2. Now I cannot choose a negative sign, otherwise the x is negative. So x must be a negative 1 plus positive 5. Okay, so that is answer. So you get a irrational number. This is an irrational number. Okay, in other words, okay, if you have infinite many terms, that is going to be square root of 5 minus 1 divided by 2. It's interesting, right? So the limit case, okay, in some sense, it's going to be a fraction number. It's getting close. So what is the square root of 5? What is the square root of 5? Okay, square root of 5. Square root of 5 is the irrational number, right? Let's go back to irrational number. It's going to be 4 plus 1. Okay, it's going to be 2 square plus 1 square, right? So actually, if we draw a rectangle consists of 2 squares, that's 1, here's 2. And this, if you already know Pythagorean theory, that's a square 5. That's how long the square 5. Okay, and that is I can explain to you now how long this number, how big of this number. This is going to be length of the diagonal of this rectangle consisting of 2 squares. Okay, consists of 2 squares. Okay, now I also mentioned the quadratic formula. So if you have equations, it's not a linear equation, right? Here's a is not going to be 0. And how do you find the solutions? The solution will be, this is a formula when I was talking about negative 2a minus, it's a b squared minus 4ac. So sometimes you get a complex number. Sometimes you get 2 real numbers. So this is a quadratic formula. Because when b squared minus 4ac is negative, you do get the complex numbers, okay? Otherwise, you always, you get real solutions, but could be irrational numbers like what I did here. Okay, so you apply this formula It's called the quadratic formula for the quadratic equation. Okay, so I got the equation here. You see, I got equation x squared plus x minus 1. You cannot solve it by factoring the function. There's no way you can factor it. So the reason is because it has complex, it has irrational numbers. The solutions are irrational numbers. Okay, so that is beginning of the advanced mathematics. And after that, we are going to study linear equations, and then word problems and number series and sequences. And finally, next semester we're going to study geometry and probability again. Okay.